Time magazine called him the unsung hero behind the internet. CNN called him a father of the internet. President Bill Clinton called him one of the great minds of the information age. He has been voted history's greatest scientist of African descent. He is Philip Emeagwali. He's coming to Trinidad and Tobago to launch the 2008 Kwame Ture lecture series on Sunday, June 8th at the JFK Auditorium, UWI St. Augustine, 5 p.m. The Emancipation Support Committee invites you to come and hear this inspirational mind address the theme, crossing new frontiers to conquer today's challenges. This lecture is one you cannot afford to miss. Admission is free, so be there on Sunday, June 8th, 5 p.m. at the JFK Auditorium, UWI St. Augustine.
I was asked, why should the African student study mathematics? Mathematics is more than memorizing the times table of arithmetic. Mathematics is more than learning how to solve the quadratic equation of algebra. The African student must study mathematics because it's a subject that nurtures critical thinking. Critical thinking, in turn, is the most undervalued experience in education. This lack of critical thinking skill explains why a 13-year-old Northern Nigerian that did not learn geometry proofs is easily convinced by Boko Haram jihadists to strap herself with a suicide bomb. To dig deeper into the quadratic equation of algebra and to be reflective of how the partial differential equation of calculus enables Nigeria to discover and recover otherwise unforeseeable crude oil and natural gas demands a significant time for reflection and thought. My passion for performing the fastest calculations began in early 1964. I was then a 9-year-old in Abo, Midwest region, Nigeria. Each late afternoon, I practiced solving 60 to 100 arithmetical problems and solving them within 60 minutes. I was practicing for the all-important 1965 Common Entrance Examination into King's College, Lagos, Nigeria. At that time, King's College was the most elite secondary school in Nigeria. The entrance examination into Nigerian secondary schools was akin to American Scholastic Aptitude Test that was at the level of a 12-year-old. That entrance examination consisted of two parts: a set of 60 questions on the English language and another set of 60 problems on arithmetic. Each problem must be solved within 60 minutes. For the 20th onward of January 1964, and in the late afternoons, and in the evening, and in the living room of our 3-bedroom house, my father drilled me with 60 increasingly challenging arithmetic problems. I used a stop clock that stops at the 60th minute. With daily practice for the forthcoming entrance examination, the questions on mathematics became easier than those on the English language. At the All Nigeria Federal Entrance Examination, I selected the faraway all-boys boarding school, King's College, Lagos, as my first choice. I was confident that I scored 100% in the mathematics portion of that entrance examination because I had been rehearsing for that entrance examination and practicing it almost daily for nearly 2 years. I was able to finish the 60-minute test in 10 minutes. At the practice sessions, I only scored above about 90% in the English language portion of that entrance examination. So my total score of 190 was not high enough to get me an admission into the very competitive King's College, Lagos, Nigeria. My failure in 1965 to get into the most sought-after secondary school in Nigeria was a big blow to my father's ego and to mine. At age 10, my confidence in my mathematical ability was supreme. That confidence stayed with me, and I was not afraid to tackle previously unsolved mathematical problems, such as solving initial boundary value problems of mathematical physics and solving them for the first time and across a new internet that is a new global network of processors, each akin to a tiny computer, that were identical to each other and that shared nothing between each other and that were tightly coupled to each other. I was confident because I was identified as very talented in mathematics and as someone that will shine in the field of mathematics. Back in early 1965, at age 10, at St. John's Primary School, Boji Abo, Midwest Region, Nigeria, my school headmaster, Mr. Okwechime, would not have been surprised if he was told that a quarter of a century later that I will be the cover story of the top mathematics publication, namely the May 1990 issue of the Siam News that is published as the news journal of the Society for Industrial and Applied Mathematics. I'm Philip Emeagwali. Why must the inventor of the modern supercomputer that computes in parallel also be a research mathematician? The reason is that the research mathematician is tasked to figure out how to reduce her mathematical fiction to our physical fact. Parallel processing was first published as science fiction back on February 1, 1922. 67 years later, on July 4, 1989, that science fiction became non-fiction, and that discovery of practical parallel processing changed the way we look at the computer and the supercomputer. It's a misconception that my research in parallel processed computational mathematics was graspable to the most brilliant mathematicians in the world. Nothing could be further from the truth. To prove my point, 1.5 billion persons used or shared their knowledge across 10 billion videos posted on YouTube. At least 1 million of those videos were produced as scientific lectures, with at least 1,000 of those videos delivered by the top research mathematicians in the world. Yet, you will not find any video in YouTube, other than mine, of course, in which a mathematician described the partial differential equations that he or she invented and described how he or she solved them across a new internet that is a new global network of processors. Back in 1989, it made the news headlines that an African supercomputer wizard in the United States had won the top prize in the field of supercomputing and won that prize for solving the grand challenge problem of supercomputing and for solving that problem across a new internet that is a new global network of 65,536 tightly coupled processors, and won that prize for solving the grand challenge problem of mathematical physics and for solving it at the world's fastest speed. I am that Nigerian, I am that Nigerian supercomputer scientist that was in the news back in 1989. As a supercomputer scientist, I had to quantify my parallel processed solution to the grand challenge problem, as well as measure the new speeds of the physical experiments that I conducted across my new internet that was a new global network of 65,536 processors that were identical to each other and that were tightly coupled to each other and that were equal distances apart from each other. Without mathematical knowledge, supercomputing across millions of processors would be an unconstrained speculative science fiction. Mathematics is to science what paint is to art, or what words are to literature. The secret to my success as a supercomputer scientist was that my father, Nnemeka James Emeagwali, attended Christ the King College, Onitsha, Nigeria, and attended that high school for the 6 years inclusive of 1942 through 47. With that level of education, my father was able to tutor me from the times table to solving the quadratic equation of algebra. The Earth's atmosphere is a sewer for pouring carbon dioxide. Each year, 38.2 billion tons of carbon dioxide are spewed into the atmosphere. That's 5 tons, or the weight of an elephant, of carbon dioxide emissions per person per year. 62 years ago, only 9.2 billion tons of carbon dioxide were spewed into the Earth's atmosphere every year. The top 3 carbon polluting countries are China, United States, and India. If the Earth gets warmer by 2 degrees Celsius or 3.6 degrees Fahrenheit, some species will become extinct. Sea level will rise 1.5 feet by the year 2100. And some small island nations could be destroyed, with hundreds of millions of refugees becoming displaced. Parallel processing is the crown jewel of extreme scale computational physics. The parallel processed solution of any grand challenge initial boundary value problem is at its mathematical core. A clarion call to solve the largest system of equations arising in algebra that in turn was derived as an approximation of a companion system of partial differential equations of calculus. 9 times out of 10, that algebraic grand challenge also underpins an extreme scaled computational fluid dynamics code that in turn contains the basic discovery of practical parallel processing that I made on the 4th of July 1989. In his White House speech of August 26, 2000, then US President Bill Clinton described my discovery of practical parallel supercomputing as the Philip Emeagwali formula that enables computers to make fast calculations.
In
insightful and brilliant lecture.